Welcome back to Cloud BI Academy. Today we are diving into the an advanced topic, simulating and identifying performance bottleneck in SQL Server. If your SQL queries are running slow or your system is experiencing unexpected lags, this video is for you. We will walk through a hands-on demo, showcase common bottlenecks, and explore how to optimize performance using execution plan, indexing strategies, and query tuning. So if you found this is valuable, hit that like button and subscribe for more SQL insights. Before we simulate a bottleneck, let's understand where they occur in a SQL Server. A performance bottleneck is a condition where one part of your system slow down the overall performance. So this topic is extremely useful if you are working as a database developer, administrator, or preparing for a technical interviews. So let's explore the different type of bottleneck, what cause them, and how you can troubleshoot and resolve them efficiently. So first is what is bottleneck? So let's start with the simple definition. A bottleneck is a condition where the performance of a system is limited by a single or a smaller number of resources. In SQL Server, bottleneck happen when the system is waiting too long on a resources like a CPU, memory, disk, or logs, and this delay affect overall performance. So there are four major types of bottleneck commonly seen in a SQL Server environment: CPU bottleneck, memory bottleneck, IO bottleneck, and blocking and deadlock. So we have a detailed discussion on these topics. So first start with the CPU bottleneck. CPU bottleneck occur when the SQL Server process consume too much of the processor capacity. This can happen due to poorly written queries, missing indexes, complex join, or use of the function in a where clauses. Outdated statics can also cause SQL Server to generate inefficient query execution plan, which increase CPU uses unnecessarily. So to troubleshoot CPU bottleneck, the first step is to find which query are consuming the most CPU. You can use DMVs. So DMVs like sys.dm underscore execute underscore query underscore states to identify the top CPU consuming queries. Then you can create or adjust indexes using recommendation from this DMV. So through this DMV, we have getting the detail of missing indexes to optimize our queries. Also, third one also replace scalar function in a where clauses with the inline table valued function where possible. If a query is causing excessive parallelism, use the option matchdop. And finally, don't forget to regularly update the statics with the update statics. So these are things we can uh, solve our CPU bottlenecks. Now next move to memory bottleneck. So memory bottleneck happen when SQL Server does not have enough RAM to store data in a memory. This forces SQL Server to read from the disk frequently, which is much slower than a reading from memory. At the end, I have show you demo also. So common cause including large queries, poor indexing, or highly number of concurrent sessions. So the causes are insufficient RAM. So causes are insufficient RAM causing frequently paging to disk, large execution plan due to suboptimal indexing, high number of concurrent queries exceeding available memory, poor buffer pool uses due to lack of indexing. So to diagnosis memory uses, you can check memory related DMVs. This setting to avoid starving the operating system. Make sure your query are optimized and only return the necessary columns and rows. Third one, also apply appropriate indexes to reduce the memory footprint of operation like sorting or joining. If you are running multiple workload, consider using resource governor to allocate memory effectively. For IO bottleneck, an IO bottleneck occur when the reading from or writing to the disk is too slow. This is usually caused by inefficient indexing large result sets or all data or log file being on the same disk. TempDB concatenation is another common cause, especially if multiple queries are trying to access TempDB at the same time. And solve this bottleneck to troubleshoot IO issues. Start with a virtual file states. So through this DMV, we found the latency on a data and log files. Apart from the stored data files and transaction log files on a separate physical or virtual disks. Next, enable instant file initialization so that SQL Server can allocate files faster when database grow. And for TempDB, create a multiple data files, same size to reduce a concatenation. And also rebuild or reorganize indexes regularly to reduce the unnecessary disk access. So what is the rebuild and reorganize? We can we will go into in more detail in our future videos. Now move to blocking and deadlocks. So blocking occur when one process hold a lock and other process are waiting for it to release. So deadlock happen when the two or more session wait on each other to release the lock, and SQL Server has to choose a victim and a rollback one transaction. So for example, at a same time on a same table, we have insert and update. So this is a greater blocking situation for us. So this problem often arises from a long transactions, lack of indexes, or high isolation levels like a serializable or repeatable read. We have discussed more on in our next videos. So to detect blocking, use tool like a SP who and DMV. We have used DMV for that search.dm trans logs. So basically, this is detect the blocking queries. Apart from that, keep your transaction as short as possible. Avoid running long transaction that lock rows or for too long. Choose appropriate isolation level. In many cases, read committed snapshot isolation help reduce blocking. You can also apply indexing strategies to reduce a lock continuation. In some cases, with no lock hint may help reduce a blocking, but use them carefully since they allow reading uncommitted data. So we covered four major types: CPU, memory, IO, and blocking deadlock. Along with their causes solution, remember proper indexing, query optimization, and proactive monitoring are the key to good SQL performance. So now let's create a control performance bottleneck in SQL Server and analyze its impact. So we will create a large data set to simulate high query load. So that's why we create a sample database for that. I also share this query with you on our description link. So first we have create a table without useful index. Like in the, we I have create a, orders table where order ID we have used as a primary key, customer ID, order date, and amount and status. So these are the column here. So this creating a table with no indexes. So now this table we have insert one manual record. So I have create a sample query for insert these records in our order table. So through this query we have insert one manual record into our order table. Sorry, I have forget to create tables. Okay. So now we have insert 1 million record into order table. So this table now contain a 1 million record, but no index apart from the primary key. So since there are no index on customer ID, SQL Server scan the entire table, leading to high CPU usage and slow performance. So now let's check this. So there are two syntax: set statics is IO on and set statics time on. So we get the execution time and all information we have getting here. So now we run our query with the. I will explain two more things here. If here you have seen display estimated execution plan and include actual execution plan. So before query, if we run display estimated execution plan, so we getting the how much time it will take and what are the cost for that. So we have getting these information here, but in detail things we using the include education plan. So when I run this query, so first I go to execution plan. So here you have seen cluster index scan. Okay, if I'm going to more detail here, so here we have found to see where our query is struggling. We analyze the execution plan here. So here we have getting the alert missing index, and the impact of this index is creating non-cluster index. So these things we have getting here. Now moving to how much execution time it will take and what is the compile time for that. So here you have seen table order scan count is 1, logical read is 5609. Okay, so we need notice A table scan, which means SQL Server is reading every row instead of using an efficient lookup. So the IO statics show high logical reads, confirming an inefficient query. So for fixing the bottleneck using the indexing. So to optimize this, we create a non-cluster index on customer ID. As per our execution plan, we have also getting this information. It is required a non-cluster index on which column? Customer ID. So first we off this statics. One second. Okay. So for creating a cluster and non-cluster index, I have already explained in my previous videos in detail. So for the creating a non-cluster indexes, this is the syntax here. Creating a non-cluster index, this is our index name. This is a table information, and this is a column. Which column we have required? It means if we using the any other column, so we have apply on a customer ID. So first we create a non-cluster index, and then we check our query. So after creating a non-cluster index, this information also display in our database level. So now after this fix, we run our optimized query again with index. First we have run our query without index. Now we have run our query with index. So first we go to into execution plan. So here is now you have seen. Now it is a index. It uses the index seek and key lookup on our order table. So notice the difference. SQL Server now perform an index seek, dramatically reduce the logical read and CPU time also. If here we have seen prior it is a about something 5000 something. Now logical read is taking us 616. So these way we have fixed our bottlenecks. After our task has been completed, so we just off this statics because it is a exceed our time. Apart from indexing, here are additional optimization techniques we have using, use covering indexes for frequently query column, optimizing join using index foreign key, use partitioning for a large table, keep your statics update for a better query optimization. So we have successfully simulated and optimized a complex SQL Server bottleneck. If you enjoyed this video, give it a thumbs up, share it with your peers, and subscribe for more SQL tutorial.